here we're doing some more problems that have to do with transversals, where you've got a couple of parallel lines and a transversal that crosses both those lines. This first one says find the measure of angle 1, so this angle down here, in the figure below, and it says PQ and RS are parallel. Well, once we know that PQ and RS are parallel, this is a piece of cake, because in a transversal you really only have two angle measures. You have, and here they've given us one, 65 degrees. This is a vertical angle here, so I know this is 65. I've got two corresponding angles down here, so this is 65 and this is 65. I don't even have to go any further than that. I could figure out that what's up here is 115 because this would be a linear pair, but I don't need to because I've already got my answer. The measure of angle 1 is 65 degrees. Let's try a trickier one. This one says, given that A and B are parallel, find the measure of angle 3. And this looks a little bit different. It doesn't really look like a transversal problem, although we do have the two parallel lines. So how do we approach this one? Well, I would suggest that you turn it into a transversal problem by extending these lines. So let's extend this line out here, and then let's extend this line. Now what we've got here actually is two different transversals. So let's deal with them one at a time. And all we really need to know is about the fact that you have corresponding angles with transversals, and then you have vertical angles that are built. So let's look at this one. We have 41 degrees down here. This angle right here is a corresponding angle to that one right there. So this is 41, and this is a vertical angle, so this is 41. Now look at this. We've got two angles in a triangle up top here. 41 plus 29 would be 70, so this is 110 right here. And we've got the same vertical angle situation going on in this x in the center. So if this is 110, this is 110, which means that these two, that would be a linear pair, right? So this is going to add up to 180, and this would equal 70. So looked a little tricky at first, but this is actually pretty simple once you turn it into a problem with transversals. Let's look at one more. This one just throws in a little bit of algebra to keep us up to snuff on that. It says the measure of angle 4 equals 2x, so that's this one right here. I'm going to just write that in. And the measure of angle 1 equals 118. And it says find the value of x for which P is parallel to Q. So we're just going to assume P and Q are parallel and somehow try to solve for that x. Well, once I've got a number here on one of these angles, I'm going to go to town writing in everything I know. First of all, I've got vertical angles here, so this is 118. I've got a corresponding angle here, so this is 118 and this is 118. Well, here's a linear pair, right? So 118, subtract 118 from 180, and you've got 62. So angle 4 is 2x and it's 62. So I can set up this equation, 2x equals 62. And then to solve for x, simply divide by 2. I get x equals 31. And that is the value of x for which P is parallel to Q. So that's a little bit of work with transversals.